Today we're going to continue looking at section 2.2, so more on functions and their graphs. Our objectives today, we're going to identify intervals on which a function increases, decreases, or is constant, and we're going to use graphs to locate relative minima or maxima. So let's talk about increasing, decreasing, and constant functions. A function is increasing on an open interval I if for any x1 and x2 in the interval, where x1 is less than x2, then f of x1 is less than f of x2. One thing that I really want to point out here is the fact that it says an open interval. Remember, when we're talking about interval notation, when it's open, that means that it's not actually included. And so notice that in the picture, you can see that there are open circles. And so we have to be thinking about parentheses. So anytime I'm talking about interval notation as far as what is increasing, then we have to have parentheses around it. We will never use brackets. Okay, so what it's talking about is if x1 is less than x2. So notice the picture, x1 is to the left of x2. It's closer to 0, so it's smaller. Notice then the function at x1 happens to be lower than where it is for the function at x2. All right, so I mean, obviously you're starting small, you're getting big. That's what it means to increase. A function is decreasing on an open interval I if for any x1 and x2 in the interval where x1 is less than x2, then f of x1 is greater than f of x2. So another thing to point out here, once again, we're talking about an open interval. So if you look at the picture, notice that there are open circles on either end. So once again, that means anytime we're talking about decreasing, we want to have parentheses around that interval notation because we are not including the numbers. But notice this time, x1 being less than x2 happens to be when you find it at the function is higher up than the bigger x value. Okay, that's what it means to decrease. You start big and you get smaller as you continue to go. Then we have a function being constant on an open interval I if for any x1 and x2 in an interval where x1 is less than x2, then f of x1 equals f of x2. So once again, everything here is on an open interval. So we are always going to be dealing with parentheses when we are naming something that is increasing, decreasing, or constant. So notice that the picture shows to be constant means that you will always have a horizontal line. Okay, nothing is going up, nothing is going down. It is always staying the same. So let's state the intervals on which the function is increasing, decreasing, or is constant. So increasing, decreasing, and constant. All right, so if we're talking about wanting to find the intervals where we are increasing, that means we start small and head big. Okay, so we're looking for where is my basically slope positive. So notice that I see from this point down here where I have it in blue to this point up here, we are dealing with a positive slope. We're starting low and going high. Okay, so that means that that's an interval where I am increasing. But remember, we're only talking about open intervals. So we always are looking at the x values, which gives us these ranges. So notice that the x value on the left there, I know the number is small, but that is a -5. So in parentheses, I have -5, and it increases until we get to the x value of -2. So I have it in parentheses. It's not an ordered pair. That is my interval notation for one part in my graph where we have an increasing function. Okay, notice that there's another spot where we are increasing. Starting here at this point, going to this point right up here, there's another positive slope. So that means that we have another open interval. Looks like it's starting at 0 and it's heading until 2. So once again, there's parentheses around it. And then notice that we actually have a third interval that is increasing. From this point here, and then I've got an arrow, so that means it's going to continue going up. We are dealing with another positive slope. So as far as x is concerned, that looks like that is the number 5. And because the end gives me an arrow where it's just continually going up, that means that as I continue to move to the right, it goes up. So we're heading towards infinity. So it looks like there are 3 different intervals where we have increasing pieces. So now let's look at where our intervals are decreasing. So if we look at the fact that going from the left to the right, on the left side, I see an arrow and it's up, but then as I'm moving toward the right, it's heading down. So that's going to be an interval where we're starting at negative infinity, because as we're going to the left, we are still going up, but it's heading towards negative infinity. And notice how it's going to stop at negative 5. Once again, we have parentheses because we're dealing with open intervals. So there's one decreasing interval. Notice that I see a second decreasing interval. Looks like it starts at negative 2 and it goes to 0. Once again, parentheses around it because that is an open interval. Looks like there's another spot where we have a decrease going on. It looks like it starts at 2 and it ends at 5. So there are the 3 different decreasing intervals in this picture. As far as finding a constant, notice that I don't see any horizontal lines, so in this case, there are none. Okay, let's look at this picture. We're going to state the intervals in which the function is increasing, decreasing, and constant. So we've got increasing, decreasing, and constant. All right, so increasing, we're looking for positive slopes. Where does it start low and head up? Well, if I'm looking at this picture, I don't see that at all, so there are none. If I'm looking for decreasing, I'm looking for where does it start up high and end low. I see one nice big continual decrease. If I'm looking at my x values from the left, I see at negative 4, I continue to go down until I get to a positive 2. Because remember, we're looking at the x values here. So it's an open interval. I've got parentheses around it. Even though there is a point at 0 and it looks like it's decreasing there, but notice how from 0 then it keeps decreasing. So that's why I connected those 2 segments together, because the whole entire time it is decreasing. As far as constants go, we're looking for horizontal lines, and I actually see a couple here. Notice that on the left, I've got an arrow pointing to the left. So that means that my x values were at negative infinity as we have this horizontal line, but it seems to end at negative 4. So there's an interval. But that's not my only interval, because I see another horizontal line making it another constant when x starts at 2. And because there's an arrow pointing to the right, I know that I'm heading towards positive infinity. All right. So those were increasing, decreasing, constant intervals. Now let's talk about relative maxima or relative minima. So a function value f of a is a relative maximum of f if there exists an open interval about a such that f of a is less than f of x for all x in the open interval. So if you're looking at the picture here, notice that they gave me point A on this x-axis. So that's just representing a number. So I mean, say it's like the number 10. So that means that if I'm looking at my function, when I go to 10, I happen to then have the highest points surrounding as far as my function goes. So that happens to be, there's a curve that's heading down on either part. So that's why that's a relative maximum. It says a function f of b is a relative minimum of f if there exists an open interval about b such that f of b is less than f of x for all x in the open interval. So some value for b, notice that I've got this curve happening where that point at b is the lowest compared to the points that are surrounding it. That makes it a minimum. So if the graph of a function is given, we can often visually locate the number at which the function has a relative maximum or relative minimum. The graph below shows the following. So notice that there's a lot going on with this picture. Let me talk about it. It says f has a relative maximum at pi over 2. So notice that that's a value that is on the x-axis. Well, why is it a relative maximum? Well, if we're looking at that x value, I happen to see the function, there's a curve to it, making that point the highest point surrounding all the other points by it. So we say that we have a relative maximum. The relative maximum is f of pi over 2 equals 1. The reason why it equals 1 is because that is the y value for which the pi over 2 is my x. It says f has a relative minimum at negative pi over 2. So once again, negative pi over 2 is a number that's on my x-axis. I see that there is a curve here where that point is the lowest point surrounding it. Notice that the y value there would be negative 1. So that's why the relative minimum is f of negative pi over 2 equals negative 1. So let's look at this example. It says the graph of a function f is given. We're going to use the graph to find each of the following. In part A, the numbers, if any, at which f has a relative maximum. And then what are these relative maxima? All right, so we're looking for maximum. So remember, that means that we're looking for points that surround other points where we have a point that is at its highest. Okay, so it's not necessarily where is the highest spot on the function. It just means that when you're looking at all the points surrounding it, it looks like that point is higher than points around it. So hopefully we notice that it looks like right here, this point happens to have points surrounding it that are lower. Okay, so notice that we're talking about finding numbers for which f has a relative maximum. That means we're finding an x value. So I would say that point right there is a maximum. My x value is 0. So I would say f has a relative maximum at 0. Okay, so that's the x value, which is the highest surrounding all the other points. So now, what are these relative maxima? So I would say that the relative maximum is, and now I'm going to write it in that function notation. So it would be f of 0 equals, and now I need to know what that value actually is. So I'm looking for the y value at that x equals 0. Well, at x equaling 0, it looks like we're at negative 2. In part B, it says the numbers, if any, at which f has a relative minimum. What are these relative minima? So if we're looking at the picture, I happen to see a couple of spots where the graph dips low and then goes back up. So in this picture, I actually have several relative minimums. So it looks like this point here kind of goes down but then dips back up. So notice that that is at an x value of negative 2. So I would say f has a relative minimum at negative 2. But then notice that also over here, I see a point that it's at its lowest because the points surrounding it are higher up. So that is an x value at 3. So I would say it's at negative 2 and 3. So it's okay to have more than one minimum or maximum. It just depends on what your picture looks like. Okay, so now let's figure out what that relative minima is. So that means that we're doing our function notation. So I want to know, where is f of negative 2 and where is f of 3? All right, so at negative 2 on the x, it looks like we're at negative 3 for the y value. When I'm at positive 3 for the x, it looks like the y value is negative 5. All right, so I want you to use the graph and determine the following. I want intervals for increasing, decreasing, constant, and then what is the relative maximum and the number at which f has a relative minimum. So pause the video and try it. All right, hopefully we noticed that, once again, open intervals for our increasing, decreasing constant. So we want parentheses around it. So I have an increasing interval going from -1 to +1 because those are the x values for which my graph is rising. I've got several decreasing intervals. So going from -infinity to -1. Okay, I know it's at -infinity because there's an arrow. Okay, also we've got an interval that's decreasing from 1 to +infinity because once again on the right side there's an arrow. There doesn't have any horizontal lines making anything constant, so there are no intervals for which f is constant. Okay, so the relative maximum of f. So where do I have the highest points? Well, that happens to be at 1. And what is that value? Well, that's when y is 2. So f of 1 equals 2 would be that relative maximum. The number at which f has a relative minima is going to be -1. Okay, so the number is the x value. What the minimum is would be -2. Okay, but they were just asking for the number, so that means you're finding the x value. If they wanted to know what the actual minimum was, then that's the y value. All right, so that's us increasing or identifying intervals that are increasing, decreasing, constant, as well as looking at graphs to locate minima or max.